Hi everyone, hope you're having a great summit. My name's Matthew Coles and I'm joined with Paul Kukel over there. So I'm a principal engineer within AWS and Paul is an enterprise solution architect. Today, we are here to talk about the golden pathways for cloud builders. Before we get right into the golden pathways, I did want to start with some of the challenges that I do see and I have conversations with engineers about all the time. Now, I know it's hard to build an application. I know that projects that you're working on, you're generally dealing with multiple languages. You might be dealing with multiple frameworks as well, libraries that you've got to learn, and you've got numerous different APIs that you'll be talking to. Your app's not really just isolated alone to itself. It might be communicating with other apps that other teams have built through APIs. It might be also communicating to third-party vendors too. And then your team gets together and you identify best practices together. And these are coding standards that you might put in place to make sure that you've got consistency as a team. People can build really easily and quickly together within that team. And at the same time, you've got pressure on the other side of the equation. It's really important for businesses to be successful. They generally need to deliver things very quickly to the market. They also need to innovate and stay ahead of the times all the time. And so there's a lot of pressure that comes into your backlog as a builder as well. And then there's also things around scalability, making sure that things aren't just going to be built quickly, but actually able to run successfully for many years. So all these things that developers basically face day to day, there are things that we can help in the cloud, right? And that's what we're here to talk to you about today. And so for today, we're effectively going to go through some of the practices that I do see, some of the tools that AWS can help with, bring into the table for you guys. We're going to go into golden pathways as well, which I'll talk a little bit more about what they are in a second. But these are really helpful things that we actually use in AWS ourselves when we develop software to kind of give really good guiders and starting points when you're starting to select what your new application might need to be hosted on infrastructure-wise. At the very end, we'll also talk about two different tools that you can't miss. So, cloud development practices. Overlaid here, I absolutely love this list here. I've collected these services that I think are really key to help you as a developer or a builder, and I've laid them out into the different stages of building. So definitely grab your phones, take a photo. You can refer back to this as well. I think this is really handy as you're working through each of those stages. But in the authoring stage, AWS is here to help you. We've got the AWS toolkit built into your favorite IDEs. We've got Code Whisperer, which is going to be an AI companion that will help you code faster and better and follow different best practices too. And then when you're building source and artifacts, there's a number of services there that will help. Building and testing is really important. And we've got numerous things there, including Device Farm, chaos engineering with fault injection simulator that Radha just talked about beforehand in her previous session if you're in the room. And then you've got deployment, you've got code deploy. Overarching all of that, you've got AWS Code Pipeline. That can actually help you all the way from authoring to deploying, having deployment happen a lot faster than if you would actually manually trigger things right throughout a pipeline. So Code Pipeline's a great tool there. And then we've also got CodeCatalyst, which you might have seen at reInvent. CodeCatalyst is a collective space that you can work together to produce quality software. Paul will cover that later. But last but not least, on the bottom, before I move to golden pathways, monitoring, managing, and securing, there are a lot of services that can help. These will just be brought into the lifecycle of your workload when you need them. You're like, okay, at the moment I need CloudWatch for logging. I need to handle secrets better. These are services that you can learn as you go. Moving into golden pathways, though, the focus of today. Now, golden pathways have been used internally in AWS to kind of represent pointers for software engineering teams within. So software engineering teams, they generally need a really good space to start. They're like, what is the best practice within our company at the moment? What should we be doing? What services should we think about using? What patterns should we follow? All these things we refer to as golden pathways, and we try and make it really easy so new teams can engage and start building with some velocity within AWS, and also current teams that have been developing for a long while, they can stay up to date with the recommended practices. And these are really relevant to customers as well, so that's why I wanted to bring them up. Firstly, infrastructure. There's many different options on how you create that. Generally, as builders, we like to write in a language that's familiar with us, and that's why CDK is so brilliant. It's also very short and succinct as a interface into creating AWS resources as well. In terms of building front-end applications, I know a lot of people are building web-based software. Amplify makes that quite easy, and it's cross-platform, so it doesn't matter if you're building a native mobile application or you're building a web application. There's several different things that will let you tap into cloud resources fairly easily and fairly quickly, and it also handles hosting if you're doing web. The focus of today really is the serverless backends with AWS Lambda. So what does serverless look like when it comes to Lambda? And then also containerized backends with Fargate. So these are the two things that we're going to dive into today for everyone. So they're also quite similar. So a lot of people come to me and they go like, I want to build an application. Should it be a serverless application? Should it be a containerized application? And they bring in all these things like, I need such and such CPU, I need a GPU, I need different RAM storage requirements. I have different requirements when it comes to what my workload's doing and how to handle that. This is a really nice way to think about it, I think. I think if you want to do GPU-driven workloads, you might be doing some machine learning. You'd definitely be driven more towards the container end of the spectrum. Compute, RAM, storage, all of these is actually just a balance on what you want with your application. But on the container side, the important thing to think about is you've got some stability to the traffic of your workload. You know that your workload's going to be long running. It needs to be consistently available. Those things containers do really, really well. On the other end of the spectrum, you've got serverless. So serverless is always going to be awakened. It's going to be triggered by an event that comes in. And so the beauty about that is you can actually have really spiky traffic patterns to your application. You might know that people aren't going to use your application for most of the hours at night. You might know that they use it certain times of the day, and you really want to spike up that traffic as soon as people start using the application that you've created, and it will be there available for them in near real time. So we'll dive into each of these two sections, but firstly, I wanted to deliver a tip. Because one thing, and you'll see tips right throughout the presentation, but one thing that I know happens a lot is people do think that Lambda is going to restrict them and serverless is going to restrict them in terms of storage. And they've got applications that might be hosting a lot of data, need a lot of data to work. You can actually tie in Amazon EFS connected into Lambda, so you can have a lot more storage than you generally planned. Feel free to get your phones out, scan the QR codes as they do come up. They will lead to the documentation for each of these things that we do talk about. But let's move on to look at serverless and Lambda in particular. Here we go. So we talked about events beforehand. Events are really the trigger to Lambda kicking into gear. The way I like to think about it is you might have created some business logic that might live within a front-end application. Someone might press a button to buy something now on the site. They might want to see things that they've brought. Each of these individual tasks that a user might perform on the website might hit up API gateway, and they might invoke a Lambda to perform that particular action. So the actions are really business logic that you've containerized into a very small unit of processing or a function. Now, events don't have to be just web-based. Events could be through data changes that you see within S3. You might have another team deliver a file to you. You might have something come up on the messaging queue that you need to process. Hey, there's an action and we need to send an end user an email per se as well. And then so your Lambda functions are going to handle all this logic, but they're also going to be able to connect into all the different AWS services as well. So that's essentially what a serverless application is for people that aren't too familiar. Now, how do I actually build my first serverless application? The first option that you do have is AWS SAM, or Serverless Application Model. So SAM is a CLI that you can install locally on your machine. You can develop all of your code locally. There's really easy, simple YAML definitions where you can put things together. Extends to CloudFormation, so you can customize further. It's really, really easy to deploy code very quickly with Lambda. Now, the more complicated your application gets, the more functions that you might have that are serverless, you might decide there's a point where it's like, I want to manage this all within one space. And that's where CDK comes in. So Cloud Development Kit is effectively, it allows you to develop in the language of your choice. So that could be JavaScript, it could be Python, it could be Go. Many languages are available for CDK. Lets you create these resources really quickly, and you can have all the resources live together within one central hub within your CDK source code repository. You've also got many different patterns if you're doing complicated pieces of infrastructure that you can refer to with the construct hub. So this will allow you to have multiple pieces that chain together to create an application that people in the industry have pre-made for you and very simply made available. So the next tip that I'm going to give everyone is run your Lambda functions locally with AWS SAM. So one of the things that developers always talk about is, I want to see what my application does really, really fast. I don't want to, deploy some CloudFormation and wait a few minutes for it to run. I want to see what happens. I want to see that reaction really, really fast. If you do use SAM, you can see that change. And I'm also going to show a tip or a secret in CDK that will allow you to see changes in the cloud really, really fast as well next. So here is a demo that I've prepared earlier. I've got a CDK application that I've created. And within that CDK application, I've got the stack. And the stack's only 20 or 30 lines of code. I'm using IAM. This application is going to talk to AWS Translate. It's going to be made up of just a simple AWS API gateway and a Lambda that is then talking to Translate, and it's going to translate some text from English into Korean. So you can see I've set up everything here. I've got a role, a policy that I'm attaching as well to let Lambda talk to the Translate service fairly easily. And then I've got my Lambda itself living within the CDK project. And you can see I've loaded in the Translate libraries. I'm basically passing in events from the front end. So these could be translate this particular sentence for me. And then I've got the source code set to English, and I'm converting to Korean with this Lambda function. So in a second, we will actually deploy this, and you'll see what this looks like. Here we go. So to deploy, I do a CDK deploy command, and you can see all the resources that it's going to create within the cloud listed there. So you can see, even though I've got 50 lines of code maximum for this application, it's going to create 10 different things on the back end for me. I can just say yes, have all of that deployed. I get an API gateway URL that I can call from my computer, and I can basically just do a curl that will send the message hi there over to my new service, my new serverless application. And I can see hi there is returned back in Korean. Now, the trick with Lambda is you can actually deploy in real time if you do a CDK watch command. So CDK watch command will actually listen to changes that I'm making within my CDK project. I could use this in a development environment, and I've just simply changed the language to convert from English to Japanese. So if I do that curl again, you can see that now I've got Japanese returns. So hopefully that looks right. If there's anyone from Korea or Japan, let me know in the audience after the talk if the translation was really good. But that's effectively a really simple serverless application that I've deployed. So before we wrap up on CDK and serverless, I did want to give a couple of different pieces of advice that I think are really vital for do's and don'ts when it comes to CDK. The first thing is, a lot of people tend to just want to use static names for what they're doing in CDK. Actually use the suffixes, the parameters that are there and available for you to use within CDK applications, because that allows you to deploy to multiple regions, multiple accounts, the exact same infrastructure, but you don't have any problems with namespaces because you're using slightly unique names for your S3 buckets and things that can't have the same name. The other thing that I do recommend is separate everything into different stacks. So think about your data in one stack, your database in one stack. Make sure to keep that separate from different services you might be using and some code that you might be deploying, because what that means is that you can safely make changes to the code end without accidentally affecting the database layer. There are things in CDK as well that will complement this, where you can set parameters to say, do not delete these particular databases and the likes, but keeping it in stacks is a really good safety measure as well. The next thing is make your app deterministic. So within your account, all your assets that you have are going to be basically set as a CDK context object for when CDK generates the application that you're trying to deploy. You can actually use things like the from lookup commands to see, what's my VPC name, what's my subnet name. You can do all of that with CDK. I do see a lot of customers that kind of combine CDK with the AWS SDKs. This is a much better pattern to keep in mind because you can just use CDK natively and you don't have to rely on APIs to return data about your account as you deploy that may or may not have changed at some point. Now, next is CDK does scope down roles and access to least privileged. So you can actually just trust in CDK to manage your roles. There are things that you can do around the bootstrap role and this and that. There's some really good blogs that you can go into around controlling the security of CDK deployments and leveraging CDK pipelines. But in general, the services that CDK will interact with, it will scope it down to least privileged. Now, last but not least is model all the production stages. So you can actually use code pipelines in the background with CDK pipelines, and you can deploy to multiple environments based on rule sets that you've set up. So you might go dev, UAT, and prod. You can have all of those deployments done and managed through your CDK code, and that pipeline through to your infrastructure all created. So the final tip before I pass to Paul is CDK NAG is a really good resource. It's on the AWS Labs GitHub. CDK NAG will actually check your CDK code against best practices, and it will let you know if you're following the best practices or if there's some things that you could potentially bring into your application to make it more secure. So definitely check out that link. Presentation will be available afterwards as well if you want to dig into it. But what I'll do now is I will hand to you, Paul, for containers.
Great. So thanks, Matt. So containers and serverless, I mean, I'm sure most of the builders in the room have used one or the other, or probably both. So when we think about containers, we often think about the difference between, what is required for longer running compute. And that's typically one of the decisions that we go down that path. So, as AWS, we've probably worked with two of the main container services, or you may or may not have. Now, if you've got a vendor-based application that required to be running containers and is certified for a Kubernetes platform, we've got our Amazon EKS service, so our Elastic Container Service. If you're building your own services, you've got a whole bunch of different tasks, you want a little bit less overhead, you want a platform that is more taken care of by AWS, and we don't really want to run a whole platform of our own on a Kubernetes platform, we've got our ECS service there. But when we talk, and Matt's talked so much about serverless, but serverless also extends far above just Lambda functions. There's a plethora of services that we consider our serverless-based services. And Fargate is one of those. So even just this morning at breakfast, I was spending time with a couple of my customers, and they're saying now all of our workloads are going onto Fargate, and we're running those on the back of ECS. So we're taking, advantage of the shared responsibility model that AWS provides by letting AWS manage, that infrastructure behind the scenes, and us just interacting with the control plane. So with Fargate and containers, and we're considering these environments, you no longer have to manage your AMIs. You don't need to worry about the patching and managing those instances and those nodes. You can scale it up and down and really only pay for what you need. But what about as a developer? And when we go back to what Matt says in the beginning, the business is always asking for work from us. Managing any of these platforms takes some time. What about if we were to take and abstract that a little bit further? And so I'm here to talk a little bit more about AWS App Runner. So App Runner was recently released in the Sydney region, so it's now available for us within the Sydney region, and has also had a couple other releases which I'll talk about on the next slide. But App Runner takes the idea of running your containerized workloads, or workloads that are supported by App Runner's specific and supported runtimes, which include Node.js, Python, and Java. And it really takes that a little bit further along that path. When you're building on top of Kubernetes or ECS, you have to go ahead and configure your load balancers. You have to define auto scaling groups, define what that looks like to scale it up and down. You have to build your own pipelines. You have to implement blue-green deployments. If something goes wrong, how do you fail back? How do you roll to an earlier version? With App Runner, all of that is taken care of for you. So you can look at your application, define it, point it to an ECR repository that has a container that's running off the back of that, and say, once I've pushed into ECR, go ahead and deploy it automatically. If something's gone wrong with my application, roll it back to the earlier version. So we've also got deploy and build, so our CI/CD is taken care of for us as well. And what about auto-scaling? App Runner does this really, really well as well. We can consider our application as something that needs to scale up and down, and we want that for resilience as well as performance and scale for our end users. So what makes an application really well suited to App Runner? As I mentioned before, one of the earlier things is considering scalability of our applications. And App Runner is used best to support applications to scale between 1 and 25 instances of your application. So that's one of the limiting factors of App Runner. However, App Runner is designed to support HTTP-based applications, whether that be a traditional MVC or 3-tier application that runs in a container or a managed environment, or something like a web API, so an API endpoint that needs to be up all the time and it is latency sensitive. It was only late last year where we saw the release of the VPC connector as part of App Runner. So this allows you to interact with any resources that are private to your account and reside within your customer VPC. In this example here, this is a relational database service here. And so for the first tip that I have today, if you don't have already, consider installing the AWS Toolkit within your IDE of choice. And this can show App Runner and related services directly within, and be able to interact with them directly within your IDE. So if you haven't seen App Runner, I'm just going to show a little bit of a demo on how we can take this a little bit easier. So we don't just have an application, but we also have the ability to manage pieces and peripherals around the application. And in this demonstration, we're going to walk through applying a custom domain to a service that I've deployed into App Runner. So typically when we have some services out there, we're giving an endpoint, so some way that our customers are interact with us. In this example here, we're taking an existing service in AWS App Runner and we're applying our own custom domain to that. So, obviously we're doing this through the console here, but we've applied the domain to that service. The service then says, okay, go ahead and add a couple of entries into DNS. We can see here that I'm adding those DNS entries into Route 53. One is the A record, that is the alias directly to the service, so the webapi.apprunnerdemo.com. The second are the couple of CNAMEs that verify that we are the entitled owner of that domain. The App Runner service will wait and check for that to become active. And then it will go ahead and apply that load certificate to your load balancer, and your service will now be operating and receiving communications on your own personal domain. And we can see here in the demo here, just for demonstrations point, this is a C# web application, and there's Swagger on the front end, and we're interacting with it. And you can see within just a couple of minutes, that is all taken care of. The renewals are all handled by the App Runner service. So no longer do I have to interact with extra services such as Amazon ACM. So the two tools not to miss. So the first one, as builders, we are constantly writing code. We are working through a series of documentation, looking up APIs, trying to figure out how these things work. Amazon Code Whisperer is a tool and a plugin to your favorite IDE or your IDE of choice, where you can use comments, so written comments, and Code Whisperer service will pay attention to the language that you're operating in, contextual areas of your code with which you're operating in, looking at things like variable names and what you're trying to do. But it will take what you're trying to implement as a written comment in your code and start to pull up real production-ready code that's been trained on AWS internal code, as well as open source projects around the world. So this is code that is ready for you to use, as well as it's following like best practices. So it also has first-class support for AWS supported APIs. For my second tip, once you're taking advantage of these AI and ML services, want to consider Amazon Code Guru. So the idea of shifting left is always there. With Code Whisperer, we're having our AI generate some of that code. When we implement Code Guru as part of our SDLC process, we can also continue to shift that left and pick up some of those security concerns before any of that code ever makes it to production. Now, Matt mentioned this really early, and we have a new service that was released last year at reInvent, which is Amazon CodeCatalyst. So Amazon CodeCatalyst brings together everything software development teams need to plan, code, build, test, and deploy applications onto AWS into a streamlined integrated experience. It enables accelerated project setup, automation of daily manual workflows, and environment creation and management and fluid collaboration between teams. With CodeCatalyst, you spend more time developing application features and less time setting up project tools, creating and managing CI/CD pipelines, provisioning and configuring various development employment environments. And for our tip for this, this is something that comes up all the time. CodeCatalyst supports multi-account deployments. So considering that, that's always a tricky piece. It's pre-built into CodeCatalyst. So check that link out. So now I'm going to give a bit of a demo and a run through of what CodeCatalyst looks like and how you expect to interact with it. In this environment here, I'm going to create a brand new project in a space that's been defined. I'm going to pick, as we do, a to-do web application. We've always got to bring one of those in. And this is a blueprint. So we're going to start with a blueprint that's got something ready for us in a couple of pipelines. You can see the blueprint had a number of different CDK deployment languages to pick from. In this instance, I'm going to configure this one to deploy into Python. I provide a name for my new piece of software that I'm going to deploy, and I check an environment so I can attach my project to a specific AWS account or multiple environments. I've also, as Matt mentioned earlier, attached a specific CD role within that environment so that I can deploy within a series of governance for my application. As part of any new software deployment, we're going to create a new repository. So I want a Git repository created where I'm going to commit and work on this code. And I'm also going to choose Python here for the back and front end CDK that's going to be deployed, as well as specify the specific region where I want those resources deployed into. So we'll go ahead and we click create project, and with just a few seconds, the CodeCatalyst application that sits outside of the AWS console has created me a code repository, so a Git repository I can begin interacting with, an environment that my team can all log into and have access to and operate in. It's created like workflows, and we'll see that in just a second visually. And it's basically an environment where I can begin operating on my software. If we look in here at the source repository, we can see that this looks like any other Git interface that we would look at. We can see my source files, our markdown files are being rendered, and we can see those. When we go to workflows, we're thinking about what that pipeline is and how we get that production. Now, workflows and pipelines are made up of a number of steps, and it's really important to be able to have and see those visually. So there's a visual editor, so you can go ahead and make those changes visually, but you can also define all of that in YAML, so you can codify the whole pipeline experience. What about when I want to start coding? Well, I want to code, but I want to use my IDE of choice. In this instance, it's going to be Visual Studio Code. When I begin adding a new feature or working on a new feature, I want to create a new branch on my repository. So I'll give my branch a name, and I'm going to pick where I'm going to branch from. Now, what CodeCatalyst will do is provision a dev environment, and this is where we've got blueprinted development environments that we can hook directly into our IDE of choice that's supported at the moment. In this instance, is Visual Studio Code. So that is making a private connection back into a dev environment that's managed by CodeCatalyst, but I can operate on my local machine using my own IDE. We can see here that I'm now going ahead and installing the dependencies for my React-based application without having to determine whether or not NPM is installed or is the right version, because this is all set up for my teams. I can also go ahead and preview and run that locally, even though all of that resource is built up into the cloud. So we can see here that that's our usual operating environment, however, I had all the accelerators of building and deploying within the cloud. I'll hand back to Matt, who can summarize up our talk today.
Excellent. Thanks, Paul. So in summary, we've covered a lot. We've looked at some of the development challenges that I've seen talking to different engineers, talked about some of the development practices, the services that might help there. We looked very quickly into the golden pathways, and I implore you all to dig more into that within the coming slide. And we've also covered some really handy tips and tricks, as well as 2 tools not to miss. So these are the resources that I think are probably going to be the most critical if you're starting off. If your team is wanting to learn CDK, they want to see how this works within a live, real project. The CDK Workshop, the extended edition, is fantastic for this. Now, CodeCatalyst is probably quite new to most people within the room. The Getting Started guide is going to show a lot more of the capability than Paul was able to fit into his very short demo today. So I implore you to check that out as well. And then last but not least is the Builders Library is a fantastic resource that you can go to find best practices and patterns as you're building cloud-enabled workloads. So we've got a final tip. Paul, do you want to come closer to me? This is going to be really corny, but we decided to do it anyway. Are you ready for the tip?
I'm ready, Matt.
Okay, so the final tip for today, and I'm going to count down so we can get this right.
All right, let's do it.
3, 2, 1 is there's no compression algorithm for experience. Now, the reason why I do say that is I've found that you can watch so many different tutorials and you can feel lost and stuck as to how to do things. The best way to learn things to the cloud is actually to go in and build your own fun little projects that you care about. So definitely do that, and feel free to show Paul and me anything that you've built as well. You'll be able to find us online in many different places. Another really good resource is the AWS Skill Builder program. So if you want to learn about cloud in particular, definitely go here. This is a great resource for everyone to tap into. Now, I wanted to say thank you, everyone, for watching our presentation. Paul and I will be available on one of the booths. We'll be near Serverless Espresso in the SheBuild stand. We have an application that we've built using C and Flutter that you can come check out. It's an IoT-enabled project. You can see that if you want. You can have a chat with us. We'll be on the floor the entire time. Please feel free to fill out the survey as well. Let us know your thoughts on our particular session. I'd like to say thanks, everyone.
Thank you.